This is video 4 in the series on rational functions. In this video, we're going to continue with the graphing of a rational function. And we're going to start with this example I have on screen right there. It says graph g of x equals 3x over x squared minus 4. And in this video, I'm going to run right through the steps that I had given in the last video, video number 3. So if you missed any of those steps, please check out video number 3 for the complete list. I'm going to flash that list of steps right on the screen right now, and it's right about there. And I'm going to run right through that series of steps to graph this function. So here we go. All right, the first step we normally do is I'd like to look for, I'm going to write this over here. So we're going to look for the horizontal asymptotes. And remember to do that. So step 1 is, again, I look for the horizontal asymptote or the slant asymptote. And to do that, you're going to look for the degree of the numerator and the degree of the denominator. So the degree of the numerator is 1, and the degree of the denominator is 2. So we said that if the degree of the numerator is less than the degree of the denominator, you have a horizontal asymptote at y equals 0. I'm going to pencil that in. So it's going to be right here on the x-axis. All right. So step 1 is to find your horizontal asymptote or your slant asymptote. Step number 2, as you saw on the steps previously on the screen, step number 2 would be to factor. So we're going to factor this function, and the numerator cannot be factored, so we have 3x over, but the denominator we can factor. Since the denominator is a difference of perfect squares, we can factor that into x plus 2 times x minus 2. All right. So that'll give us our factors, and then we're going to go into step 3. And if you remember from the last video, step 3 was the real heavy lifting step. That's where we found the vertical asymptotes, the holes, and the x and y-intercepts. So I kind of break it down into little pieces like this. So part A is where I look for the vertical asymptote. And if you remember from the previous video or video number 1 in this series, to find the vertical asymptotes, all you do is you look to the denominator, and any factors that are remaining, which haven't been canceled, from the numerator, those are the factors that are going to give us the vertical asymptotes. So you're going to set x plus 2 equal to 0, and then x minus 2 equal to 0, and then we're going to solve, and we're going to get our 2 vertical asymptotes. So we're going to have a vertical asymptote at x equals negative 2, and then 1 at x equals 2. All right, so those are going to be our 2 vertical asymptotes, and I'm going to put those on the graph also. So we will have one right here. And again, the asymptotes are going to be our guides. Remember, the graph, the rational function graphs will not cross the vertical asymptote, but they can cross a horizontal asymptote. All right, so we get our nice guidelines for the asymptotes. In 3b, if you remember from the last example, this is where we're looking for any holes. And since I didn't cancel anything up above, since I didn't cancel anything in the original function, there are not going to be any holes created. So the holes are created by values that make the numerator and the denominator 0, and there's nothing canceled, so there's no x values that are going to do that. We won't have any holes. No holes on this graph. All right, so I'm going to move this up just a little bit. And then the next thing we would look for would be in 3c, we would look for the y-intercept. And remember, for the y-intercept, which is standard for any function, all we're going to do is substitute a 0 in for x into the function. And if I come back up here, here's my original function. We have g of x equals 3x over x plus 2 times x minus 2. And for this, since we didn't have any canceled factors, we even could use, if I erase this, we could even go back to the original function to do some of this work too. make life a little easier. So I think that's what I'm going to do. So to find the y-intercept, we're going to go back to the original function, which was g of x equals 3x over x squared minus 4. And then we're just going to substitute a 0 in for x. We're going to have g of 0 equals, so we're going to have 3 times 0 over 0 squared minus 4. And this is basically going to get us 0, negative 4. So this is going to give us a y-intercept of 0, 0, which incidentally will be an x-intercept. So we can put that on the graph as well. So I'm going to change the color. And so we can see that this graph, even though it has a horizontal asymptote, will intersect the x-axis. So the last thing we're going to do, I'm just going to move this up, and then I'll come back to the graph, is we're going to, actually I'm going to erase this, just to give myself a little bit more room down at the bottom. And the last thing we're going to do in 3D is we're going to find the x-intercept. And if you remember from the last video, again, what you do is you set your numerator. So you would set your numerator equal to 0. Any factors that haven't been canceled. So we have, here's the original function, g of x equals 3x over x squared minus 4. And then all we need to do is set the numerator equal to 0. So we're going to make g of x equals 0. And we're going to set the numerator, which is just the 3x portion. And we're going to solve. And we knew this already because we found the y-intercept and the last step was 0, 0. So my x-intercept would be at 0, 0. All right. So, we knew that, but, I'm just going over the steps again on how to find the x-intercept. So there's our graph. Well, there's a part of our graph. There's all the guidelines, and we only have one intercept. So now what we need to do is do our test regions. So I'm going to erase all this. So when we make our test regions, they're going to be at any place along the x-axis. Remember, I'm going to label this from negative infinity to positive infinity. That's what we did in the last example. So we're going to use the entire x-axis, and we start at negative infinity, and then we kind of ride along the x-axis until we hit either a vertical asymptote or an x-intercept. And you can see I have a vertical asymptote at negative 2. So what we're going to do is create our first test region. And we always start the first test region with negative infinity, and then we go to that asymptote, so it's going to be negative 2. All right. So what we need to do now is continue this along. So I'm going to create the second test region. And remember, the second test region is going to start where the first test region ended. So we're going to start with negative 2, and we're going to continue on, the journey through the x-axis here. So we start at negative 2, and we stop again either at an x-intercept or a vertical asymptote, and we're going to stop here at 0. So we're going to go from negative 2 to 0. That's going to be our next test region. And we're going to have another test region. So we'll have the third test region. And again, the third test region will start where the second test region ended. So we're going to start at 0, and we're going to go to, picking up where we left off, we're going to go from 0 and stop at this vertical asymptote. So it's going to go from 0 to 2. And then we have one more region because we have to continue along until we hit positive infinity. So the last test region, we have 4 of them on this graph. The last test region will be from 2 to positive infinity. All right. And then all we need to do, like I said, you can pick as many points as you want in these regions, but you really only need one to determine whether your graph is going to be above the x-axis or below the x-axis. That's really, what the test point is for. We know, the graph is going to kind of ride along the vertical asymptote, and, in a lot of cases, it's going to ride along the horizontal asymptote. And in the previous video, I gave you the algebraic approach of determining whether a function will reach a horizontal asymptote. So why don't we pick some points? And I'm going to start with in this first test region. So we need a point from, we're in here, from negative infinity to negative 2. I'm just going to pick negative 4. And we'll just see. I just want to go a little further away from the asymptote here. So we have g variable here. So we have g of negative 4. So we're going to do 3 times negative 4 over negative 4 squared minus 4. So this is going to give us negative 12 over, and it's going to be 16 minus 4. Negative 4 squared is 16 minus 4. So this is going to give us negative 12 over 12. So we're going to get a value of negative 1. All right? We have the value here. We put in a negative 4, and we got out a value negative 1. So that was our test point. So I'm going to plot that on the graph. We're going to put negative 4 and then negative 1. So what that tells me is that every point in this region from negative infinity to negative 2 is going to be below the x-axis. So again, I could pick another point. I could do negative 5. I could do negative 3. We could keep going here. However, I know the general behavior of these graphs, and what's going to happen is this graph is going to kind of ride along and go down towards the vertical asymptote this way, and then it's going to ride off and go towards the horizontal asymptote that way. All right, so there's our first test region. There's our first test point. So let's go to the next one. So we need to pick a point in the region negative 2 to 0. So let's do negative 1. So we're going to do g of negative 1. And it's going to be 3 times negative 1 over negative 1 squared minus 4. And then we can just simplify this. So this is going to give us, in the numerator, it's going to give us negative 3. And then we're going to have 1 minus 4. So this is going to be negative 3 over negative 3. So this is going to give us a value of 1. So we have the test point, negative 1, comma 1. So I'm going to plot that. We have negative 1, 1. So again, in this region, what it's telling me, right here from negative, it's a small region, negative 2 to 0, what it's telling me is all the points are above the x-axis. So if you remember how they're going to behave, the graph, and again, you could plot another point here. You could pick a fractional value here. So this graph is actually going to go up this way towards the vertical asymptote. This is going to behave that way. And then we're just going to finish this off. So we have 2 more regions. So I'm going to go over here, and we're going to go now we're from 0 to 2, so we're going to pick 1. So we're going to do g of 1 and substitute that into the function. So we have 3 times 1 over 1 squared minus 4. So this is going to give us 3 over, basically, the bottom is going to simplify into negative 3. So this is going to be negative 1. I'm going to substitute it in a 1, and we got out a negative 1. So that's my third test point. And I'm going to plot that. That's 1, negative 1. So now this tells me that in this region here from 0 to 2, all the points are going to be below, and they're going to go towards that vertical asymptote. All right? And then we just have one more region to finish as I move this over a little bit. So why don't we did negative 4 on the other side. Why don't we do 4 here? Let's substitute this in. So this is going to be g of 4. Just to keep things consistent. And then we have 3 times 4 over 4 squared minus 4. So this is going to give us 12. And if we simplify this out and substitute the 4 in, we're going to wind up getting 16 minus 4, which is 12. So this is 12 over 12, which is 1. All right. So we substituted in a 4, we get out a 1. So here's my value. I'll just change the color. And again, you know, the behavior of this graph, since it isn't going to, there's no other asymptote to go to, just the horizontal asymptote here and the vertical here. There's no other X-intercept. So what's going to happen is, again, this graph is going to go down towards the asymptote this way, and then it's going to go up towards the vertical asymptote that way. So that is the shape of that graph. That's how it all works out. So those are all the steps. And what we're going to do is we're going to continue this series and complete this with the next example. And in the next one, we're actually going to do a graph that has a slant asymptote. All right? So I'll see you in the next video, next example. Take care.